Alrighty, so chapter 16, practice problems. There's actually two sets of practice problems. I believe this is the one where the name is like questions with answers or whatever. But if someone wants to double check me on that, that's fine. There are a lot of the same questions, but they're not exactly the same. So let's do this one. So which of the following is an acetal? Does anyone know what the general structure of an acetal is? If you have no idea, you could just let me know and we can like build up. Ignore my water bottle crying. I don't know why it does that. Ooh, okay, so we're very close. So, yes, we have a carbon, and that carbon is attached to one R group, one H, and then two OR groups. And the reason it's not two R groups down here is actually because this is an acetal, so it has to be an aldehyde base. If it was a ketol, it would be two R groups, like so. So the trick part of this question is that they give you this ring structure and they give it to you in condensed formula. So you're essentially looking for one carbon that has at least two oxygens on it, or it has two oxygens on it, not at least. So this carbon has two oxygens, however, this one is double bonded, so that's wrong. Here, that's attached to three oxygens, and one of them is double bonded. That has to be wrong. This carbon is attached to one OR, two OR, one CH3, and one H. So this checks out. And then here, in the last one, this carbon has an oxygen, this carbon has an oxygen, but there's not one carbon that has two oxygens on it. So that one's out. So the answer has to be this one, which would be C. Also, it just occurred to me that the answers are not under the question in this one, so clearly it's not the one with the answers on it. My bad. Okay, how do we feel about this one? Any questions? Does it sort of kind of make sense? Oh no, go away. Makes sense. Okay, good. This thing is being so obnoxious. That's fine. Okay. Cool. So, number 9. Today in SI, we talked about what a thioester is, and so this is a thioester. The reason I bring that up is so I can kind of show you the relationship between a thioester and an ester. So thio, whatever, is when we replace the oxygen with a sulfur. So if this is a thioester, we know that a thioacetal is going to be an acetal, but the O's are replaced with S's. So which one of these answers looks like an acetal where the O's are replaced with S's? So you don't necessarily replace all the O's every time. For example, the thioester, you only have one of them replaced. But for the thioacetal, yes, you would replace both oxygens. So with that in mind, you can get rid of these two answers. We can also get rid of this one because it has a double bonded S, and we know there's no double bonds in thioesters. So now we're stuck between C and D. So what do y'all think? Okay, so someone said C. Good try. Let me draw out C and D so you can see it in. Okay, someone said my brain's not working today. That's okay. It's the day after Halloween. I know that people, maybe not everyone, but I know a lot of people today were going through it. So it can be kind of like I explain and you guys kind of chill day today. We're all allowed to have those. So C has one SH group and one SR group. And D has one SR and another SR. So this guy is a hemithioester, and this one is a thioester. Because, wow, I'm so sorry. A thioacetal. I saw thioester from the corner of my eye, and I just wrote it down. I apologize. So, a hemiacetal is 1R, 1H, 1OH, 1OR. So if it has an SH, that means it's a hemi. And the two SR groups mean it's a thioacetal. So the correct answer would be D. I know this is a little bit of a weird one. You don't have to worry too much about thio groups, but this question could potentially pop up. Alrighty. So this one is super similar to the one we did before. So it's asking for an acetal. And once again, I'm going to draw the general structure of an acetal. And I want to look at the answer choices and figure out which one could potentially be correct. Let's kick out some obvious things first, right? So we're looking for a carbon that's attached to two oxygens. This carbon has an OH, this carbon has an O, but it's not the same carbon. So there's not one carbon that has two groups. Goodbye. Same exact thing here. So one O is all the way here, one is all the way here. There's no carbon that connects them. Here we do have a carbon with two O's. And we do, in fact, have an H there. So the R and the H are good. Now we're looking for two OR groups. OR, OH. OR, OR. So as it turns out, this is a hemiacetal, and this one is an acetal. So the correct answer would be B. And Lauren was absolutely correct. Yay! Okay, so it seems like you guys are picking it up, which is good. For the cyanohydrin question, I don't know if anyone was here last week when I briefly talked about it, but essentially, don't worry too much about the cyanohydrin one. Just know that if you have this plus this, you're going to get, for example, if you had this ketone plus this reaction mechanism from above, so I'll just write, you're going to get, this part stays the same, and you make a carboxylic acid. It's really weird. Just know that that would be the answer. And so you can get rid of B and C because there's no double bond. And then if you draw this out, you would get COOH versus this one. Not me trying to figure this out and being so bad at it. Okay, ta-da. See. So out of these two, A looks the most like this. Again, this is not one of the 7 reactions we did together. Don't worry too much about it. I don't really ever see this pop up on the exam, but it has once or twice in the past, so just know it, but don't spend too much time worrying about it. Is that fair enough? Okay.
Hey Rose, you said a ketone plus the cyano creates a carboxylic acid?
Yeah, so it would have this like base on it, and then it would have a carboxylic acid. And the carboxylic acid just goes wherever the O was. So we replaced the O with a carboxylic acid.
Okay.
Great question. Do either or have either of you looked at the Wittig reaction yet? Have not. Okay. So let's do some examples and then after of the other stuff, like the rest of the chapter. And then the Wittig reaction is like a weird one. So after we do the other practice problems, we can go back to it and I can show you like the actual reaction and then we can practice it. Does that sound okay? Okay, cool.
Is this the one he did in class today, like at the end of class?
I had
Was
to
it
leave
there?
class early to go to my tutoring session. So I'm not
Oh,
sure
okay.
what like the last 10 minutes what happened, but
Okay.
probably. He was doing a review of chapter 16 today.
Yeah, I think he said something about Wittig.
Yeah. The Wittig is a fun reaction. It's not as awful as it seems when you
Okay.
get to
All
it.
right.
Okay, so the reaction questions on your exam are going to look something like this, which is why I tell people you have to refresh on the naming stuff. So he says benzaldehyde in methanol and HCl. So looking at this, which reaction from chapter 16 does this look like? And you can look at your notes. Ooh, it's chilly.
Is this like acetal ketol reaction?
Yes. Cool. So this is
Um,
acetal
what's
specifically, correct? What was that?
what's the difference between the acetal ketol and the gem diol, like
Great
with
question.
the
So
reagents?
the gem diol is water and catalyst. Oopsie. And it can either be acid or base. And then the acetal ketol is an alcohol with a catalyst.
Thank you.
You're very welcome. And a little note for the acetal ketol reaction, it only goes to completion with acid. So if you have base or no catalyst, you stop at the hemi. Doesn't matter for this example because we do have an acid catalyst. So our product will keep the exact same bottom part. So this will stay exactly the same. And you add 1, 2 oxygens, and each of them has an R group on it, and the R group here is a methyl, excuse me. So each of these O's have a CH3 on it. Ta-da! So which of these answers, I know some of them are in condensed, or all of them are in condensed formula. Which of these look like the right answer? Yes, it is going to be A. Perfect. How I would go about answering this is first, I would say, oh, these two have double bonds. That can't be it. This one has a chlorine. That can't be it. So we're automatically down to A and D. And then why is this one not correct? Because it looks almost the same as the correct answer. Or not almost the same, but very similar. It has OH instead of OME. Perfect. Okay, awesome. We're going to skip 15 because you don't deal with this stuff in order to. This is a very good example. Okay, so we have two big steps in this reaction, and they're two very different reactions from two entirely different chapters. So for this step, we react benzene with this guy, and what reaction do you think that this is? Hint, it's from chapter 15. And I will draw out the reagent, but I would really love for you guys to practice drawing them out on your own as well. The big dead giveaway for this should be the AlCl3 and the double bond, which we also call an acyl group. So what reaction do we think this is? Friedel-Crafts acylation. Cool. Perfect. And we know that in a Friedel-Crafts acylation, we just kick this guy off and we stick it to the benzene ring. So we get benzene and we add, bam. It's over just a tad so it's not squished. Okay. So from here, we have a second reaction, and this is also kind of an iconic reaction because we have MgBr. So what is MgBr?
Grignard.
Grignard, cool. So we're going to just go ahead and make this into the Grignard reagent instead of drawing it the ugly way. And we have a CH3CH2, so that's what it's going to look like. And the Grignard reagent is essentially going to attack here. So we end up with, let me keep the color coding. So we end up with an OH. Actually, let me be super thorough. make that blue. And let's make this purple. Sorry, I'm trying to stay organized, but I realize I have not been organized at all. Okay, here we go. Now it's color-coded. So step 1 was the Friedel-Crafts acylation. Step 2 was the Grignard reaction, and then I put this in instead of making a whole new step, but that's the protonation from the acid at the end. So which answer looks right? Number 2, I agree. So when I answer this question, I would immediately see, okay, that can't be it. Okay, that can't be it. And then I would think to myself, okay, I didn't add a Grignard here, so that can't be it. And then between these two, this is where students kind of get confused because they're like, oh, they look at this and they look at the answer choice. They're like, oh, it was a Friedel-Crafts alkylation, right? But you have to remember when you add a Grignard, it has to add here, not on the benzene ring. That may have been redundant if you guys already understood it, but I hope that's okay.
Hey Rose, I have a question.
Yeah.
For the Friedel-Crafts acylation, we removed the chlorine and then I just don't see how we stuck it on.
Okay. So essentially what we do is we take this bond and we just erase this, and then we stick our benzene ring to that.
Oh, I see. No, I see it.
Yay. Cool. And then I'll give it another second, and then we can go on to the next one. Okay, so this next one is really similar to what we did a couple minutes ago, but it's saying...
One more second.
Yes, okay. Thank you for letting me know.
Okay, we're good.
Okay, cool. So this one is really similar to one we did a little bit ago, dissolving benzaldehyde in methyl alcohol establishes an equilibrium with what? And that's a really weird way to ask this question, but he's essentially just saying, if you have this plus this, what do you make? Right? And so what's the big difference between this reaction that I have drawn out and the one I had previously drawn out? I think the second to last question.
Oh, this one, you're not reacting it in acid.
Yes, exactly. So the big difference here, no acid catalyst. So what was the little asterisk that I gave you last time? What's the difference between acid versus no catalyst?
So acid, it goes to the completion, but with no acid catalyst, it will be the hemi product.
It will be the hemi. Perfect. So we're going to keep the bottom part exactly the same. So this part stays the same. We add one OR group, but on the other side, we keep an OH, and that is the hemiacetal. So which answer is correct?
Is it A?
Mm-hmm. And this actually is one where like you could just tell by looking at it once you've practiced this a couple times, because you know that you can't have a carbonyl present in the acetal ketol reaction, and this one has 3 OR groups. So that makes no sense. So A is the only one that makes sense.
Okay, got it.
All right, we're going to skip that. I guess we can do this one. All right. Yeah, okay, we can do this one. So they're giving you CH2, CH3. I said that backwards. CH3, CH2, COOH. I hate that I do that upside down, so I'm going to redraw it. I apologize. Wow, why can't I draw today? Okay, and we're reacting this with PCl5. Anyone remember what PCl5 does? Hint, it's from chapter 11 or 12. Think
So
PBr3.
replaces the alcohol but keeps the stereochemistry.
Yes, so we don't have to worry about the stereochemistry now because it's double bonded, but absolutely right. So we're going to go from OH to Cl. So we go like this. And now they ask you to react this plus benzene plus AlCl3. So what kind of reaction is this? It's Friedel-Crafts acylation. Cool. And so again, we're just going to kick off the chlorine and attach it. I think this might be almost exactly the same thing that we got last time. So we get, bam. Not exactly the same, but very similar. All right, so at this point, we're reacting with NaBH4. So not a Grignard, but what kind of reaction?
Reduction.
Reduction. So NaBH4 will reduce a ketone to what?
Secondary alcohol.
Secondary alcohol. Perfect. So we end up with this. And if we look at the answer choices, no O whatsoever, double bonded O, no O whatsoever, double bonded O, OH. So the only one that makes sense is number 3, or C.
Are you missing a bond in
Yes,
your
I am.
reduction? Okay.
Yeah, there we go. I don't know why I kicked that last carbon off at the end, but so how we feel about this one?
Like a failure, but it's okay. Let's go.
No! Why like a failure?
I don't know.
It's at this point in the semester where we start putting a lot of things together. So it can be overwhelming, especially if you've kind of thrown everything from the first half of the semester in the garbage. So don't feel too bad if you're not getting it at first. Um, just try to go over like chapter 11 and 12 and recap some of the stuff like reduction, Grignard, oxidation, um, and reactivity trends. And then we can also talk about it here.
All right.
Okay, we're going to ignore this one, ignore that one, ignore that one.
Same.
Okay, this is fine. So, propanal. Yeah, that is a really big thing. So basically, she said that it makes sense when you're explaining it, but then once you look at it later, it's like a different language. I definitely relate to that. And something that I realized was a problem for me was I was like listening to someone explain it, but I wasn't practicing the problems on my own. And one of the drawbacks of like the virtual tutoring session is that like most of the time people don't want to share their screen and like be writing on the screen because it's hard and not everyone has like an iPad to do that on. Versus when I do it in person, like I make everyone draw it out themselves on the board, so like they're getting the hands-on thing. Um, so when you're actually doing problems, you can send me an email. Unless you're Kareem, then I won't respond. But
Wow.
I'm kidding. I'm kidding. But yeah, it's helpful to actually be doing the problems and then have someone like help you along the way. So I definitely see where you guys are coming from. But let's try to do this a different way to make it easier or more helpful for you guys. So how about I show you a problem and then for each question I give you like 2 minutes to work on it together and you can like talk and chat and whatever. And then I'll just try and dictate what you guys tell me and we'll see if that works out. Because it hasn't worked in the past, but we have a smaller session today, so maybe it'll go okay. I don't know what I'm saying. But I will give you guys a minute to do this one.
Okay, I'll try it. Open.
And then whenever you're done, just let me know. I want to give you enough time to do it so you don't feel rushed, but I don't want to make you guys like sit here forever if you're already done.
Wow, I actually did it.
Yay!
It was a mess. I had to go through some stuff to get it done. I did it.
Yay! Okay, so tell me what you guys did.
So first I drew out propanal, and of course it's an aldehyde, and we're reacting
Awesome.
it in acid.
1, 2, 3. Acid, yes. And methanol. Cool.
Methanol,
Okay.
yeah. So, um, because it's in acid, we're gonna add two OR groups. So that's gonna replace the double bonded, the carbonyl oxygen.
Cool. So we're going to replace it with 2 OR groups. So what did you get as your final answer?
C.
Okay. So, Lauren, do you see why it's C? I'm sorry if I exposed you, but there was no one else here, so I was like, I don't know if you would be upset by that. But okay, cool. So it's a good thing that you didn't pick A or B because those were like the silly answers. And then the OH versus the OCH3. I see why it's kind of easy to get mixed up between those two, but in this case, since we had acid, it would have two OR groups. Bam.
For a
Yay.
question like this, we wouldn't, well, we might have to. I was gonna ask if we wouldn't have to like try to solve it like what we just did to just look at the answer choices and choose. But then it
Yeah,
could also be none of the above, so
that's true. That's true. It's not often none of the above. So if you're like really short on time, doing it that way is completely fine. Um, just if you have the time, maybe just draw like a little bit of it out so you just make sure you're on the right track. Um, but yeah, if you get to a point where you can just read that and see in your head what it should look like, or like in general, like it should be two OR groups and there should be this many carbons, whatever, that's fine.
mhm.
Okay. We're gonna ignore that one. Not there yet. Okay, we can do 27. I know it's very similar to the ones we've been doing. And then just let me know when you are done. And while you guys are doing that, I actually wanted to ask, um, so I know you guys are signed up for like the 6 to 7 hour, but like I open it up for both hours. I think there's only one person coming in later, so I just wanted to know like what time are you guys planning on staying until? Just so I don't like rush you at the end if you guys have to leave or cut you off if you're in the middle of something you have to go.
I could stay till I have to go at 7. Oh. I have a study session at 8 for by exam, but I could stay like till 7:45 or so.
Okay. Cool. Sounds good.
Yeah.
All right, Lauren. So since you have to go at 7 after we do this one, do you have any specific questions you want to go over? Or are you okay just continuing what we're doing? Okay, cool. And then we're gonna also ignore 28.
Wait, is it the exact same thing like the other one? Like 24?
It's very similar, but not exactly the same. There's very tiny differences.
Okay.
And that's the thing with this exam. A lot of the questions are very similar, just with like tiny changes in them, which is good because it's not too difficult, but it's also bad because people sometimes gloss over important things and read too fast and get the question wrong. So be very careful for this exam. Also, just let me know when you guys are done because it looks like I'm very concentrated on something, but I'm just looking at my bookshelf. So
Looking at all those books you can now burn because you don't need them no more.
no, even better. So
Listen.
I did my master's at the med school, so um I would hang out there all the time studying. And when the students graduated from med school, it happened like two or three times where they came in and they were like, "Are you a pre-med?" And I was like, "Yeah." And they were like, "Here's all of our books." I was like, "Okay." So
Ah, wow.
I have like a shelf of like when I get into med school books, and now I'm just looking at them and I'm like, ah. But I'm also like, I was trying to
Oh,
decide if I'm insane if I start like reading through some of the stuff now because I have like a pharmacology flashcard thing that someone gave me. So I'm like,
girl,
what if
what's wrong with you?
I just want to be ahead? Like
You
I
have
took,
issues.
I really do. I really do. Let me. Okay, this is gonna take just
You're
one second.
supposed to be resting, like you just got
I
in,
I'm
like
just trying to make myself excited for this stuff again, but literally, so I took integrated morph 1 and 2 in the master's program, and it's kind of like human morph except they make it like the first year of med school's anatomy class. So, I've literally been going through and
wow.
hold on. I have all these notes. So, I
Wow.
have been since Friday just like rewriting all the notes and making them look pretty and like
Yeah.
revisiting all this stuff, and I'm just like, I'm insane, but also
Yeah.
it's giving
You're
me
gonna be
serotonin, so I'm just
ahead.
gonna let it happen.
Yeah.
Okay,
Yeah.
anyway, back to this.
It
Nope,
is
that's
so
not what I want.
nice. It's so
Ah,
nice.
yes, okay, but yeah, I'm just like, all right. So Lauren says B, and I'm gonna have to agree with her.
I didn't get that.
Ah, what'd you get?
I got the same one as above, but you said there was a slight difference, so I'm waiting on you to tell me what the slight
Ah,
difference is.
okay. So yes. So for the one above, we had HCl present. So,
Ah,
1, 2, 3. Here we have methyl alcohol again, but there's no acid. So we're going to have one OH, one OR. And these two are just here to trick you because they use the carbon in the middle, not the one on the end. So both of those are wrong. This one has a double bond, so it's out. And then between this and this, it really comes down to paying attention to if there's acid, it's two ORs. If there's no acid, it's one OH, one OR.
got it. I got tricked.
And that's how he does it. But now you won't get tricked again.
Yes.
Oh, we're gonna skip that. Uh, no, no, no. Wow, great questions. No.
Ooh, Wittig.
Yes, the Wittig ones. I think we've pretty much run out of questions that are not the Wittig ones. So let's go into the Wittig reaction right quick. And that is in here. Okay. So all right. So the Wittig reaction happens in there's like three chunks to it. So the first one is making the ylide, which is the Wittig reagent, and it's kind of similar to the Grignard reaction where we had to actually make the Grignard and then we did the Grignard reaction. So making the ylide is we have an alkyl halide and they are going to give you this step followed by this step. And when you do that, you essentially replace the X with the P, and that forms a plus charge. So you're going to steal this hydrogen and make the ylide. I know it looks complicated, but it's just one of those things where just kind of know it. It's not like the actual step-by-step reaction mechanism isn't too big of a deal.
Mm-hmm.
And just know that the ylide has two resonance structures. So both of these are the ylide. This one has a negative charge and a positive charge. This one is neutral. He could ask you a question of like, which of the following is the ylide? And you know that both of them would be correct. So the actual Wittig reaction mechanism looks terrible. And that's why I've created my own way to do it. So let me show you the real way to do it and then my version. So essentially, in the first step, we have this guy, this negative charge, that attacks the carbon of the carbonyl, kicking these electrons up, and oxygen uses those electrons to attack the phosphorus, and we make a box intermediate. Once we make the box intermediate, oxygen and phosphorus have a very high affinity for one another, so they want to be together. So oxygen is going to use its lone pair to attack here and make this bond. Phosphorus then lets go of this bond, so it breaks and gives the electrons to the carbon. Carbon doesn't want to have a negative charge, so it makes a double bond here. And that double bond forces this bond to break. So we get this. And I know that was very fast, especially if you were trying to draw this out. So I can definitely repeat that slower if you would like me to. Yes, okay. So in the first step, this guy is going to be the nucleophile. It attacks the carbonyl carbon, which makes these electrons go up and essentially get used to attack the phosphorus, which makes a box intermediate. And then this box gets broken up into two products. So the way it gets broken up is these lone pairs from the oxygen go here to form a double bond because oxygen and phosphorus really like each other. Phosphorus then wants to let go of this guy because it doesn't want to be tied down to it. So it breaks this bond and gives those electrons to carbon. Carbon is then going to use those electrons to make a double bond to this carbon because it doesn't want to have a negative charge. And once we form this double bond, this carbon has to let go of this bond because it doesn't want to have 5. So it gives those electrons back to the oxygen. So it's almost like a reverse Diels-Alder, if you want to call it that. I mean, that's not the actual name, but like if you want to think of it that way. So that's like the scientific way to do it. The Rosemary way to do it, I'm going to make a new quiz and give you a new... Okay. So the Rosemary method. So we have a ketone, right? And that ketone has R1 and R2. You could think of this as a little creature, a little molecule creature. It's an R, not a... You guys never let me rest. The Rosemary method. So we have this little creature. Also, of all the things I was saying, that was okay. Okay.
That
Sorry,
was the
I just
thing
got
that you
so
got?
thrown
Was
off.
that what you were going to say?
Yeah.
You're so mean.
I just got so thrown off. And then I wanted to tell a story, and then I was like, that's this first. Okay. So, yes. Ketone animal has two little arms called R1 and R2. And we're going to react that. That's supposed to be a plus sign. With this guy. And R3 and R4 are its legs. So we have a little creature with R1 and R2 arms, and then we have a little creature with R3 and R4 legs, but no arms. And this guy has no legs. So we're going to play Dr. Frankenstein for a second, right? Because we're freaks. The first thing we're going to do is we're going to cut off the heads of both of these guys. Just chop them right off. Now that you've cut the head off, we're gonna do some experiments, right? So since we are freaks of nature and we're bio majors, right? What we're gonna do is we're gonna stick both of the heads together and see what happens. So I'm gonna stick the double bonded O to the PPH3. Why am I so zoomed out? Okay. And then on the side, all right. So I usually get up to do this demonstration. Let me not knock anything over though. So we have a pair of arms and a pair of legs left, right? So we already made a two-headed monster. The oxygen is frowning because its head was cut off. But I guess since he's with someone he likes now, he's like, no. There we go. So he's still upset about his neck being cut off,
I
but
use that emoji all the time, and I'm pretty sure I use it incorrectly, but I still use it anyways.
same. I don't think I use any emojis correctly, but that's fine. Okay. So now that we don't have any heads, we have arms and legs. Let's put the arms and legs together. So I have R1, R2 attached to R3, R4. Lauren said I use the thumbs up exclusively. You know, that's fair, but also whenever someone uses the thumbs up emoji, for some reason I think they're mad at me. I don't know why I've decided that, but in my mind, it's like thumbs up means, oh, I don't like you enough to give you a decent response. And I'm like, bad brain.
Oh my god. Wow.
I mean, I don't actually like, do anything about it, but in my head, I'm just like, I should check up on that. Maybe they're upset with me. Um, Anywho's back to the Wittig. So, okay. So I can either have my arms this way, or I could put them on this way, right? Forwards or backwards. And it's probably too zoomed in and you can't really see what I'm doing, but that's fine. Same thing with my legs. I can have them forwards or backwards. So for this Wittig reaction, we can switch up R1 and R2. And we can switch up R3 and R4. So we could get something like this. I was too lazy to redraw it. And those two are stereoisomers of one another. And both of those can exist, right? So we can switch up R1 and R2. We can switch up R3 and R4. We cannot flip-flop this way, though. You cannot flip one of your arms for one of your legs, right? So whenever you see one of these guys, I want you to, like, consider this the middle of the double bond. You cannot flip-flop that way. But you can flip-flop this way. And you're right, Lauren. I was not lazy. I selectively saved my energy and time. I'm just smart. And tired. All right. Wait, Kareem, are you also... the thumbs up It comes back to me. How long have you been doing that before I noticed?
For a while. Oh, what's wrong? I've been doing it for a while. You didn't notice.
That's so fun. I appreciate that you stuck to it because that tickled my funny. I'm gonna take this off. All right, so how do
Ooh,
we feel about this
getting
so
a
far?
show.
Huh?
Good. Oh, I thought we were getting a show. I was like, wow.
Stop, I'm dead. Actually, when I turned the camera on at first, I was like, this shirt is see-through. That's why I put this one on. I was like, we don't need anyone seeing anything.
Right? It's all
Ah,
chemistry and biology anyways.
we're all chemists here. Oh, we're all biologists here.
Yeah.
All righty. I almost made the worst joke and then I remembered I was recording this.
Yeah. Don't.
I should probably. I wish I had the energy to crop things out and care. But it's fine. It's fine. All right, so let me zoom out in case you guys wanted to see this beautiful drawing. How do we feel about chapter 16 now that we've done a little bit of practice?
Better.
Yay. How do we feel about the Wittig one? Does it seem kind of sort of okay? That is the
Yeah.
whole Wittig reaction, yes. This one is the most straightforward one of this semester. At least the way I do it. Okay, so let's go back to the practice problems. And let's do a couple. There was a really good one up here, but we didn't. Here it is. Okay. So we have this guy, and we have PPH3, and then we have C6H5Li. So when you use those two in order, we end up with replacing this carbon bond with the bromine to a carbon that is double bonded to PPH3. He will pretty much never ask you for F, but if he does, it's just the intermediate where you have a single bond and it's a plus charge. So that would be F. But you can pretty much always skip that step and just get to G. Once you have G, they give you the ketone they want you to react it with. So in this example, you get this plus this, and I'm going to reorient it just a tad so it's easier to look at. So I'm going to put the P, pH 3 pointing up. That would leave a hydrogen pointing here. So we cut off the heads, bam, cut off the heads, bam, and we stick the arms and legs together. So we would get, this attached to this. And does it really matter? Oh, sorry. Where do I see the PPH3? Great question. That's my bad. So pH is just a phenyl. So PPH3 looks like this. And he probably won't give you like the name of it, but it's triphenyl phosphate. Ta-da. That's my bad for not telling you. And then the next thing people usually ask is, well, why'd you draw the two benzenes next to each other instead of on opposite sides? It doesn't really matter because both stereoisomers exist as long as you know that one carbon has a benzene and a methyl and the other carbon has a benzene and a hydrogen. You should be able to find the answer, which is what?
So it's definitely an alkene, so it can't be B, C, or A. So it's either D or E.
Cool. So this one has an
And
OH. This one has a ketone and a ketone, so that's wrong. So between C and D, how do we tell which one's correct?
so benzyl methyl, benzyl. So D is correct. Let me check E.
Ooh, are we
Benzyl.
sure? Because this is what D is telling us. It says C6H5
Oh, that's
attached to a
CH2.
CH2, which is attached to a CH, and that C is double bonded.
I see it.
Yeah, so it's a tricky one. Versus this one shows you CH3CH, which is this side, and then the CH3 C6H5, that would be this side. I didn't get a chance, I didn't give you a chance to look at it before I gave you the answer. I apologize. But does this sort of kind of make sense?
Yeah.
Okay, good. I know you had to go at around 7, Lauren, so I'm sorry for keeping you, but does this make sense? Okay, good. Yay.
Take a picture. Hopefully I look back at these pictures.
You know,
I
I
honestly
feel that.
never do. Yeah, so
I really do feel that. It's one of those things where it's like, I want to believe I'm going to be a good student, but I know that I'm not.
yeah, in my heart of hearts, I know.
Precisely. No, literally, Lauren. Literally. I probably have like hundreds of screenshots that I should at this point go back and delete from like biochem and like genetics because I'm like, I'm clearly never gonna look at them again, but my brain is like, no, what if you need it one day? And I'm like, there will absolutely never be a day where I need this, but sure.
Yeah. I think there was a meme with like Stevie Wonder with like a camera, and that was like the caption, me taking screenshots, knowing fully well I'll never look at them again.
Precisely. It really do be like that. Okay, let me find.
Yeah.
Okay, so while I find this, what I was gonna say earlier is what's it called? Yes, okay. So when the name thing happened, I was like, really? That's what you choose to notice? The reason I started laughing was because one time a friend of mine was like, "Oh my God, those ducks are gonna die." So we went to save the ducks and we ended up like jumping in this little pool. Not pool, it was like a little thing, like a decorative thing in front of the College of Medicine. I'm sure you've both seen it before. And we're like jumping in there and like getting ducks out, right? And long story short, we had to take one of the ducks with us inside and take it to like a shelter place wherever they take care of ducks. And I literally walk in, I have a duck in a box soaking wet, and Chris comes in and he looks at me, no comment, but then he asked me something about work and I was like nothing, nothing, like And he was like, yeah, I mean, that's pretty standard Rosemary stuff. And I was like, where? Like, what in the world?
He's so used to it.
That's what everyone, I'm kind of like, yeah, you're just. And I texted a picture of the duck to my sisters. I was like, oh my gosh. And before I could get a chance to, like, explain what happened, they were like, you can't just take the ducks. What are you going to do with that? Why are you stealing the ducks? I was like, it's like, why does everyone think I just saw a family of ducks and went, you know what? He will be mine. Like, but I guess yeah, that's fair. I am this way. So they are free, right? Like, nobody's stopping me, clearly. I got one. I could have had 10 if I wanted to. They were just sitting in the
Wow.
pond. Yeah, the duck was okay. So it like got separated from its family because they were all stuck in the pool and they couldn't get out. So we were trying to take them out, but this one jumped into the other pool and we didn't notice. So after the family was like long gone, we found him in the other pool and we searched all over campus, but we were like, it's not really logical for two people to go all around campus and check under every like bush. So we just took him to the sanctuary. That's what it's called. And they emailed me a couple days later and we're like, oh, he's doing all right. But he was tiny. He was like this big maybe, and his
Oh,
heart was pounding so hard. I was like, "Oh baby." I know. I felt so bad for him. I really thought he was just going to have a heart attack from the stress. I felt so bad. Um in the moment it wasn't funny at all. And I don't know why I thought to take this video, but now that I know he's okay, there's a video of me with a duck in my hand just sprinting across campus to like unite him with his family, and I don't even have him in a box. I'm just holding him and he's like bouncing along in my hand. It cracks me up so hard. Anyway, I just felt like you needed to know that about me.
thank you for sharing that.
You're welcome. You're welcome. Okay. So this question is kind of dumb. We're not going to do V, but we're going to do W. And the reason it's dumb is because this is a chapter 17 thing. So we're going to look at this guy, and I want you to tell me what W is.
Wittig.
And, okay. Bye, Lauren. The
Bye,
duck story
Lauren.
was just too much for you. I get it. I'm just kidding. Have a good evening.
Thanks, Lauren.
Hmm?
Oh, she said you too, so I was saying thanks.
Ah. I thought it said love you for a second. I was like, what? I was like, ooh, okay. It like took me back for a second. Whew, okay. I'm too tired to be doing this, but that's okay. So for this one, the setup of it is really weird, so I'm gonna redraw it for you. Um, so bam, 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 bam.
Oh, he did this one in class, I think. Did he?
Did he?
I think so.
You know what? I don't. You don't need that. Plus V. Okay. W. P. PH3. I guess this is nothing. All right, so this isn't much prettier, but that's okay. So down here. So essentially when we see this, we're going to split it up into 3 reactions. So this is reaction number 1. This is reaction number 2. And this is reaction 3.
There's a lot
So
going on.
there is a lot going on, yes. And this should give you the final product, yes, okay. So my bad for not drawing it out. So these kind of questions aren't necessarily hard. It's just so much going on in one picture that it tends to really confuse people, which I totally understand. But all right, okay. So then, I'm so sorry, my iPad is being dumb. Okay, so this would be reaction 3. And for this one, he's asking you to go backwards essentially and give him W. So what we're going to do is we know that the Wittig reaction is between a ketone and the Wittig reagent. So we know that whatever is here was the Wittig reagent because that plus this make that. So if we work backwards, we zoom in here, we can split this guy up into 2 pieces. One side had to come from the ylid, one side had to come from the ketone. And if we look at the ketone they give us, it's 2 ethyl groups. This side is clearly not 2 ethyl groups. This side is 2 ethyl groups. So we're going to say that this side came from ketone. Therefore, this side had to come from the ylid. So if we work backwards, we get I'm so sorry, this is a mess. Right? And then if we go back again, what was that?
Yes, I was agreeing.
Okay, cool. And then if we go back from the ylid, we have to replace the PPH3 with a halogen, and there's no way for you to tell which halogen it is, so it could be any of them. So, if he were to ask you about the Wittig reagent, you would pick this one. If he asks you for W, which is the alkyl halide, you would give him this. So, that's not supposed to be a double bond. I'm so sorry. So, which one of these answers looks like that?
Bromocyclopentane.
Mm-hmm. Yay.
What was question 30? Wait, don't scroll down. Okay, what was question 30?
That was it was this from question 30, but it had like 2 questions associated with the same picture. And for this, you need information about chapter 17. So we skipped 30 and we did 31.
Got it.
Cool. All right. So another one. Come on, bro. Oh, here it is. So, which Wittig reagent would be used to synthesize that? So, if they give you nothing else besides the final product, I want you to go through, cut this guy in half, and you could have 2 sets of reagents possible. So, you could either have the Wittig reagent here plus the ketone here, or the aldehyde, excuse me, in this case. Or you could split it up so this guy is the aldehyde and this guy is the ylid. Do you kind of see how I split it up? It's almost like, yeah, it's almost like Orgo 1 where you did like the hot KMNO4 or whatever, and you just cut it in half and put an O. So now these are your possible options. So out of these, you have to pick the possible ylids. So those are your 2 possible choices. So which answer do we like?
2. We like 2.
And any
Two
other ones?
carbons. Two carbons. IV has three carbons, so no. No. Two carbons. Would one as well?
Yep. Yay! So the answer would be E.
Yay.
Yay! Seems like you're getting this stuff. Very good.
Yeah.
Okay.
Where are we in SRL chapter 16 still?
No, we finished chapter 16 today and we just started 17, but we only like did naming. So I can show you
Okay.
what we did. Okay. So 53. Acetals are unstable in the presence of which of these? So the question it's really asking you here is acetals go all the way to completion in acid catalyst and they stop at the hemi in base catalyst or no catalyst. So what that means is acetals are stable in base and they're reactive in acid. So if it's asking you which one is it unstable in, would we pick an acid or a base?
Acid.
Acid, cool. And then the only acid here is A. So that's the answer.
Awesome.
Cool. All right. So we can do, we're gonna skip 52, but 54.
I
I'll
think he
have you,
did this one in class.
yeah. Do you remember?
So, was it hydros phenylhydrazine?
Not
Wait.
phenylhydrazine.
So it says the compound that is produced by the reaction of an excess benzaldehyde with which compound? Okay, a hydrazine.
Yes. And essentially, another way you could go about this is the only excess reaction we're going to do in this chapter is hydrazine, because it's the only one that can produce this like double structure.
Mhm.
Cool. All right.
What happens in the reaction? Um,
What was that?
what happens in this reaction? It's like
So, have you
benzaldehyde.
seen have you seen the hydrazine reaction?
Yeah.
Okay. So it's essentially just the hydrazine reaction, right? And you would get this. And then if you have another molecule of benzaldehyde, this nitrogen would undergo the same reaction and it would just get the benzaldehyde on here. So it's pretty much going through the same exact mechanism twice.
Okay. And we would remove that H2 when it goes through the second
Yep.
reaction, right? Okay.
Yep. Yay.
Awesome.
Okay. Do, 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 do. Is this
For
16?
the
These
for the one that
ones,
says reformatsky, is that just the general reactivity, like that we already know?
um, I
50, not 52. You were just on it like before 60. Um, yeah, 58. Is it that
so
like aldehydes are
you
more reactive
won't be
than
asked that
ketones?
probably because you don't need to know that reaction. But he will definitely ask you a question for like the blah, blah, blah. For the reactions in chapter 16. He'll say like, what's the order of reactivity for nucleophilic reactions? Excuse me. Um, so you're not expected to know 58, but you would be expected to know 59.
Okay. Oh yeah, he did this one in class.
Do
And
you
I think
remember the
he said
order?
the answer was B. Yeah.
Well, why though?
You're like, how the hell did you remember that?
Oh,
Um,
for real?
so steric hindrance and electronic effects. So IV is the 4 is the least sterically hindered. I want to say that's methanol, formaldehyde.
Methanol. Yeah.
Yeah, so methanol is the least sterically
Well,
hindered. So
yeah. Yeah, it's the common name is formaldehyde, but it's probably methanol. Go ahead, sorry.
yeah, so that one would be the least sterically hindered. So it would be the most reactive. And then ethanol would be the second. And then is that a ketone? Propanone would be the third. And then 5 is so bulky, so it would be the last.
Perfect.
Because yeah, those
Awesome.
3 tert things.
Yeah, the terp-butyl groups.
Terbutyl, yeah.
Cool. Perfect. Okay. So then, did he talk about stability of gem dials?
Yeah, he did this one. This one was A, right?
Yes, but why?
Because it had the electron withdrawing groups, which were the fluorine.
Perfect. Okay, so 61 is not a question that should come up on your exam, but it sometimes does, and it's A. You haven't learned about tautomerization. That's in chapter 18, but, you know, Dr. West do be wildin' sometimes.
Yeah. Did he sound off today to you?
Uh, he kind of always sounds off. Do you mean like sick or just like weird?
Just like sick.
Yeah. His okay, nobody understands what I mean, but his accent sounded kind of different.
Like I heard you said it sounded British, but I don't hear it.
Not British.
Like
It was just less
Australian,
less New Zealand, if that makes sense.
New Zealand. Okay, okay.
I don't know.
I don't hear it. I don't hear it. Like every
It's
word he says in the lecture, I repeat it. Benzene, Viking. I just repeat it so that I'm learning chemistry, but I'm also learning an accent.
yes. I love his accent. Methane.
Methane,
We the first couple weeks,
evening,
Katrina and I just sat in the back and we were like NMI, NMI,
enema.
just back and forth the whole time, and he would definitely hear us, but he didn't say anything. It was great. Truly a great time.
Uh, I could see
Okay.
me and somebody doing that. Okay.
So are you doing Orgo 2 SI? Is that what you want to do?
Um, they asked me to do a demonstration for Orgo 1 and or Orgo 2, and I did it
Ooh.
for Orgo 1 using an Orgo 2 concept.
Ooh, wow, look at you.
Yeah, so I don't
That's
know.
very exciting.
Are you gonna be working next semester? Probably not.
Unfortunately not. I just am so done.
I know, I know. I'm glad you waited until I came along to be done.
Me too. Your class is a
Yeah,
wonderful class for like the send off.
yeah. Thank you for staying for us.
My pleasure. Hopefully I'm passing the torch to you and someone
Oh,
else
or
who hopefully wants to do
someone
Orgo 2
else.
SI if you
Yeah.
don't end up doing it.
Had to ace this class first, like one hurdle at a time.
Fair enough. Fair enough. I
Yeah.
don't imagine you're not going to get an A, but it's fine.
Oh.
No pressure. Okay. Wait, I don't know why I'm stopped on this one. Yeah, that's pretty much all the practice problems for this packet.
Mm-hmm. Um, okay.
Okay, so what are you
I'll try
thinking?
to. We did like what? We did like probably like 20 questions. So like from the packet, I
Yeah.
just need to know like 20 or so.
20 or so, yeah. There were a couple that we skipped just because they were super similar, or we didn't talk about like the stereoisomers. So these two I recommend you doing, but do this after you've practiced everything else a couple times. Because
I
it
remember
gets
you
kind
saying the answer to 63 was A, like in a previous session with Lauren, right?
of yes.
Okay.
Yeah, because that's the only one that's not symmetrical.
Only one of these reactions will produce a product which
Actually,
at least
this one you don't need to know how to do this or really this. So it's not a great question, but if you just want to do A and D for practice, that's fine.
um what's the answer to the question though?
Off the top of my head, I don't know. Let me see.
Okay.
62C.
This is the one with okay. Yeah, no.
Yeah. So you don't need to know BRZN. That's a whole different reaction. I don't know why it's in this packet, but whatever. All right. So what do you want to do?
Do you want to start the chapter 17 packet? Like, could we do that?
Sure. Okay. Let me show you what we did in SI today.
Oh, by the way,
Yes.
has anybody like asked you for your books for your MCAT prep as yet?
No, and I completely forgot that I mentioned that before. Do you want some?
Yes, please.
Cool. Do you want
Um,
Princeton or
I
Kaplan?
don't. Um, Kaplan. Which one? Which one do you recommend?
Um, so I liked the Kaplan books better, and a lot of people, there's a lot of debate on it. It's a lot of personal preference, but I just thought for content review,
Yeah.
Kaplan was a lot more helpful.
Okay. One sec. Like I got some from my friend. She's going to FIU med school. It's
Nice.
Herbert Weinworth College, something like that. I want to see if she gave me Princeton or Kaplan. Let me check. Wait,
Okay.
what was your year for them? Like what year?
I think it was a 2020
Okay.
or 2019. I don't have them in my room, but I can let you know.
Okay, so she gave me the Kaplan 2019 to 2020, and it's one, two, three, four, five, six books. Orgo Chem review, Gen Chem review, Physics and Math review, Behavioral Sciences review, Biology review, and Critical Analysis and Reasoning review.
Okay. So you have all of them.
So it's just six of them? And say
Mm-hmm.
just six, like it's not a lot.
Yeah, just six, like it's not a lot. There's also like I can let you know what I have. I have one book that's like how to prepare for the application cycle, and then there's one that's like extra science concepts or like high yield science concepts book. I don't know
Mm.
where they are right now.
Now, I'm just gonna email you when the time comes and then look out for no answer.
Got you,
Prefer
got
to
you.
do it that way.
Wow, it did took a second to register what you said.
Okay, so since I have Kaplan already, um, I could do the Princeton. And I plan on sharing with like people from my year group anyways, like
Okay.
studying together. Because I know like
Oh,
me and Trinity, you know Trinity, she's like the SI leader for biodiversity.
yeah. The tiny little
Yeah,
cute. Yeah.
yeah. Yeah, I think I'll be studying with her, so
I
I'm just
definitely recommend having a study buddy. It's really, really helpful to like teach and hear and teach and hear. The only
yeah.
thing I will say, as someone who has trouble with people sometimes. If you realize that the people you're studying with aren't going at the same pace as you or aren't as serious about it as you are, don't be afraid to find a new study group. I wish someone told me that before I started studying. So
Okay.
just
Yeah.
don't feel bad about it, because like even if you're like, oh, I don't want to make a friend feel bad, the MCAT's super important and you don't want to like budge it up, you know?
Yeah. Mm-hmm.
Yeah. But yeah, that's it.
Yeah.
Um, so yeah, okay, let me just make sure I have everything together and send me an email and I'll get my stuff figured out and I'll respond to you.
You give me Dr. West vibes. I'm
No!
sorry. I am so sorry, but you do.
You know, the worst part is I didn't start out this way. And I'm now imagining like Dr. West started out all bright-eyed like I did, and then as the semesters went on, this is what he became. And
Yeah.
now I am becoming the same thing, and I'm like,
I'm looking
oh
at the
no.
like rate my professor, and I don't think he's that bad, but like on there, like the first few reviews I saw, they made him out to be like a monster, and I'm like, he's not that bad. Calm
Really?
down.
He's not that bad. Like he's annoying sometimes, but he's not like the worst professor in the world.
Yeah, the
He's just
way they
not
were
very
putting
helpful.
it. Yeah, but not a lot of professors like, go through problems with you that you might get on the exam. Like he could make the course 10 times more difficult by making us know the actual reactions and um you know
Yeah,
that's
I
my
really do
opinion
think
still.
like I think the worst part of this class is not ever feeling like you know 100% what's going on, like just because Dr. West is a little bit disheveled and sometimes
Disheveled.
he'll be like sometimes he won't even tell you like what's on the exam until like 2 days before. So that's the I think in my opinion that's the most stressful part. But I think he's pretty lenient and what his like thought process was, what he told me like a couple semesters ago was I can give them the answer key to the exam and they're still going to have a C average because there's going to be people who don't care. And I was
Hmm.
like, fair enough. And he was like, I really don't need to try to get a C average, so why should I be an asshole? And I was like, that's fair enough, you know?
Yeah.
So I don't know. I
Why
think,
people like
and
this?
besides the timing of the first exam, I think this class is pretty fair.
Hmm. Yeah. So far it's been fair, yeah.
But yes. Okay.
Okay.
So all we really did was we named these guys. Ah, darn it. We named these guys, and I'm pretty sure Dr. West did that in class Friday. But some people were struggling with the names. So carboxylic acid, ester, amide, we've done those before. If you have a halogen, it's called an acid. Sorry, I thought I was
Halide.
going to hiccup. It's an acid halide. And then sulfur is a thioester. And then if you have two carbonyls, it's an acid anhydride or just an anhydride. And then
Right.
the order of reactivity still talks about electronics and steric effects. So the less donating that the groups are, the better it ends up being. So at being an electrophile, I should say. So this guy is the only one that has an electron withdrawing group. So electron withdrawing group is going to make this more delta plus. So that's the most reactive one. And then between oxygen, nitrogen, sulfur, the highest electronegativity is oxygen. So these guys are going to be the most reactive. Acid anhydrides are more reactive than carboxylic acids and esters because it has a better leaving group. So it has a bigger leaving group that's more stable. And then between sulfur and nitrogen, sulfur has the higher electronegativity, so it's more reactive. And then the amide ends up being super stable in comparison to everything else, so it doesn't want to react.
Mm-hmm.
And then naming of esters. People, for some reason, tend to get like super confused when it comes to naming esters. But essentially, I want you to think first comes this side. So whatever's attached to the oxygen. And then comes this side. So whatever's attached to the carbonyl carbon. And then the suffix. So in this case, we have 1, 2, 3 carbons here. So it's a propyl, 1, 2 carbons, ethanoate.
Mm-hmm.
This one is just the flip-flop, so it's ethyl propanoate. And I'm going to have you name this one for me.
Okay. 1, 2, 1, 2, 3. Could I call that isopropyl butanoate?
Cool. Isopropyl butanoate. Or the IUPAC name, because that's the common name. The IUPAC would be 1-methyl ethyl butanoate.
Why is it 1-methyl? Like, is the methyl on carbon
This
1?
would be 1, and this would be 2. So this is the 1-methyl, and then this is the parent chain, which is the ethyl.
Okay, got it.
Cool. Alrighty. And then the biggest difference between chapter 16 and chapter 17, they have a lot of similar looking reagents, so you have to be careful. The biggest difference is the starting material. In chapter 16, we used aldehydes and ketones. Chapter 17, we're using carboxylic acid derivatives, aka these guys. So the big difference here is that these guys have leaving groups. So instead of doing addition reactions, we're doing substitution reactions. And Dr. West said that he considers these non-reversible because the nature of this reaction is to go from more stable to less stable. I'm sorry, more reactive to less reactive. So we're increasing stability as we react. And he said that it's not energetically favorable to go backwards. So he's saying that it's not reversible.
Mm-hmm.
Yeah. Okay. So that's all the conceptual stuff. I don't know if you want to get into the reaction mechanism stuff because we only have a couple minutes left, but we definitely can if you want to. I just don't want you to feel rushed.
Can you scroll so I could see like what's under that one? Like not up but down, like the ones we
Oh,
haven't
we
done.
haven't done any of this yet. This was all we
Okay.
got to in SI.
Okay. Okay, I'm fine.
Okay.
Thank you so much.
You're welcome. Good luck studying and good luck on your exams tomorrow.
Thank you. I need it.
You're going to do great.
All right, I'll see you. And remember my books, the Princeton.
Yes. Yes.
They're mine.
Yes. I got you.
Okay.
Okay. Bye.